We understood from the principle of product law that a raised to the power of x all raised to the power of y is equal to the a raised to the power of x, y. Also, alternatively, we have that b raised to the power of x can also be written as a raised to the power of x multiplied by b raised to the power of x. So product law applies for terms inside the bracket raised to an expression of power. Now we have these 4 examples, these 4 questions, and we're going to solve them all together. And you can give it a try now by pausing. Just pause the video right away and try to solve them. So let's begin with question number 1. We're given that x y squared all raised to the power of 4. Okay, now we will consider this second principle an extension of the product law and say that x in this case is a and y squared in this case is b. So this will give us x raised to the power of 4 multiplied by y squared raised to the power of 4, because for simplicity's sake this can be written as ax multiplied by b raised to the power of x, and this will be equal to this. Now going further, we can apply product law to this, and this will give us x raised to the power of 4 multiplied by y raised to the power of 2 times 4, and this will give us x raised to the power of 4 multiplied by y raised to the power of 8. And in simple terms, we can bring them together and say it is x raised to the power of 4 y raised to the power of 8. Now let's consider question 2. Question 2 says 1 over 2 divided by 4p all squared. Now 4p is an entity that is squared, but 1 over 2 is not in bracket. So we can say this is 1 over 2 into the bracket of 4 raised to the power 2 multiplied by p raised to the power 2. Okay, let's stick to the normal brackets before we move on to the use of square brackets. Now this will give us 1 over 2 multiplied by 4 squared is 16 multiplied by b squared. Now to open up the bracket, a 2 in 16 will be left with 8 p squared. Alright, let's try question number 3. And number 3 we have minus 3 ab raised to the power 3 all raised to the power of minus 2. Now just like we did in number 2, this will give us minus 3. This will be considered as an entity, but like an entity within an entity. So we will split it considering the power law of minus 2. So this will give us a raised to the power minus 2 multiplied by b raised to the power 3 raised to the power minus 2. Now in this case, let's apply our square brackets. Now we have minus 3 into a raised to the power minus 2. We'll apply product law to this, and we'll have b raised to the power 3 multiplied by minus 2. Therefore, we'll have minus 3 a raised to the power minus 2 multiplied by b raised to the power minus 6. And in effect, we can bring them all together and say it is minus 3 a raised to the power minus 2 multiplied by b, or b raised to the power minus 6. Now we see that these ones, minus 2, powers of minus 2, powers of minus 6, are negative index, So we can rewrite them as minus 3 times 1 over a raised to the power 2 times 1 over b raised to the power 6, which can be written as minus 3 over a squared b raised to the power 6. And finally, the last question for this lesson, we have 5a squared b raised to the power 3c all squared. 5a squared b raised to the power 3c all squared. Now, in our previous questions, we have been seeing just two terms in the bracket, and this applies to this principle that we have two terms here, just a and b. But in this question, we have how many terms? We have 1, 2, 3, and 4 terms. How do we go about it? We recall again that our product rule says a raised to the power of x or raised to the power of y is equal to a raised to the power of x times y, and ab raised to the power of x will be equals to a raised to the power of x, b raised to the power of x. And this principle can go on, and we say ABC all raised to the power of x will be a raised to the power of x, b raised to the power of x multiplied by c raised to the power of x. And we can go further up to any term, a raised to the power of x, b raised to the power of x, d raised to the power of x. And we can stop at the fifth term of terms in the bracket. That's a raised to the power of x, b raised to the power of x, c raised to the power of x, d raised to the power of x multiplied by e raised to the power of x. Now we are dealing with the fourth term. Okay, that's 4 terms, and this will be applied here. So let's solve now together. We have 5a squared b raised to the power 3 multiplied by c all squared. Now we take the terms one by one and we apply the product law on them. So this will be 5 raised to the power 2 multiplied by a squared raised to the power of 2 multiplied by b raised to the power of 3 raised to the power of 2 multiplied by c raised to the power of 2. Now 5 squared is 25. If you apply product law to this, you will have a raised to the power 2 times 2. If you apply product law to this, we will arrive at b raised to the power 3 times 2, and we'll have c raised to the power 2. And this will give us 25 multiplied by a raised to the power 4 multiplied by b raised to the power 6 multiplied by c squared. Now in essence, combine them all together and we have 25 a raised to the power 4, b raised to the power 6, and c all squared. Now with this, we have been able to establish the fact that indices questions are diverse, and the principles means that we apply the laws just as they come. Now in our next video, we will see how we can combine all the 5 laws that we have learned in a question. Okay, maybe in a series of questions, we'll see how addition law, subtraction law, the zero index, the negative index, and also the product law can be applied in questions. So see you there.